All right. Greetings and welcome to the second half of the implementation for the Eagle Dive VR. Now we're going to get into spatialized audio. I'll talk a little bit about also some of the features a little bit that we're going to specifically be dealing with in regards to this particular project. But I think it would be useful to have a little bit of an intro to Steam Audio itself in terms of how to get it and how to put it in a project, basically, if you needed to do that. At this point in time, the Eagle Dive VR already has the Steam Audio already installed and configured in it. What you're going to do, though, if you want to get it yourself for a new project, is you want to go to valvesoftware.github.io and specifically Steam Audio. So Valve Software, GitHub.io, Steam Audio. You can also just type Steam Audio in Google and get the same exact link. So you'll want to go here to the Downloads option, and you'll want to go to the Unity plugin. And then you'll go to the Unity package. And when you do that, it will just automatically download the Unity package. And it has a Unity package extension in it, I think is what it is. Has this beta19.zip. So it starts out as a zip file. And you'll want to basically uncompress that zip file. And when you do that, you'll get a bunch of different things. What you want to look into in there is the bin. I believe it's the bin. Yep. So bin for binary. Bin Unity Steam Audio .unity package. And in order to and you have to go and look for that inside Unity itself. So let me show you how you do that. They may change this before too long, but we'll see what happens. For now, you go to the Assets menu. You choose Import Package, Custom Package, and then you go and download the package you want. In this case, you go here to the Downloads. In my case, this was already has set up at Resonance Audio, but we can go to Steam Audio, which is right down in the S's. Steam Audio. Yep, there it is. So right there, under the bin, under Unity, and then Steam Audio Unity package, you click Open. I'm not going to go through the next step. And what it does is it displays all of the things that are going to be in the package that it will then import. And you can click Import in order to do that. We're not going to do that. But this is what you would do in order to import all of this stuff inside Unity to be able to use it. And there's more stuff beyond that. Once you get it inside the project, you do have to kind of set it up a little bit in order to configure it. There's a couple of things that and there'll be more things to talk about in terms of the configuration aspect. So we're going to go here to Edit and then Project Settings. And this is both similar for Mac and PC. Edit Project Settings. And then what you're going to do is you're going to go to Audio. And then over here under the Spatializer plugin, you'll want to select the Steam Audio Spatializer. I actually have two of them installed here, but, not a big deal. You can also click the Ambisonic Decoder plugin, and that will be the Steam Audio Ambisonics as well. So Steam Audio Spatializer should be for the Spatializer plugin. Ambisonic Decoder plugin should also be Steam Audio Ambisonics. We're not actually going to be doing any Ambisonics in this particular project, but we will be doing the other stuff. Okay, so that is that. Okay, so to get into our program here, what we're going to do is we're going to look for our Eagle Wing Flap object, which is in this case called Flappy. And we're going to go into our Eagle Wing Flap object. And on our Eagle Wing Flap object, we're going to add component all the way at the bottom. You can't quite see it in this particular situation, but you can basically see it if we go to the, I think if we go to the inspector, it may not work that well. Let's just see. It's not that great, no. And anyway, at the very bottom is an Add Component button. We'll basically add component. And what we're going to do is from this menu, we're going to type Steam. And here, I'll tell you what. Well, let's roll this puppy up here so we don't have to get it in the way. Click Add Component. There we go. Now we can go to our inspector view, and we'll see something there. There we go. Cool. So we go Add Component. We could type Steam. I think I didn't type the right word here. I think I typed Steam. So then there's lots of different options, and what we're looking for is Steam Audio Source. Now, what you can do if you want to, by the way, if you want to narrow those choices, just type Source, there's only going to be either an audio source or a Steam audio source. So you can basically choose that way. It's faster to look for things. So what you'll want to do to make things be spatialized inside Unity, you'll want to make sure that you click Spatialize in order to make that happen. Okay? So you'll want to make sure that that's done. Now, for our audio clip, we wanted flappy. So, by the way, another way to look for audio clips is we can click that little dot there, and then we get various things. And if we knew what the name of our file is, we can narrow it down, you know, and look at it that way. If not, we can just look at it this way, or you can move this slider all the way to the right, and you can look at it by name. If you don't like it by overview, you know, so lots of different options here. So we're going to go with flappy and do that. We're not going to play on awake, but we will loop it because it will sort of turn on and off the loop. And again, we're not putting it in the mixer just yet. We'll work on that, but we're basically doing it this way right now, clicking the audio source and then putting into the Steam audio source after that. Okay? So we can talk a little bit about the Steam audio source, how it works. Okay? There are basically two big sections to this type of component, effectively, okay? And one of them basically is direct sound. In other words, direct sound placement, you know, relative to the listener that's going to be in the scene. So the listener is just a component that sits on the camera or wherever objects really, and it basically is going to position the object relative to that listener, essentially. Now, our listener in this case is our ears, and it will be basically where our ears are going to be in the space of the game. So, so depending on where we put that, then basically this sound is going to be, you know, relative to that, positionally speaking. This is using HRTF to basically do all of that positioning correctly. And there is a lot of options available. There's both direct sound and also directivity in this particular thing. In this case, what you want to do is you will want to choose, and there's lots of different options here to look at, but you can have an option to have direct binaural. Again, this is going to be one of these kinds of situations where it's sort of like a seasoning in the sense that, like, some of these sounds will sound really great with these options on, some of them will sound terrible. So you'll have to just use your ears and determine whether the sound is improved or not improved by this quality. There's no guarantee just by turning on an option that it's just going to make everything sound perfect. So what you want to do is basically just test this out and see if you like the results, essentially. You can have interpolation between different HRTFs, and that could be either as nearest or as bilinear. I found that bilinear actually works probably the best for this particular sound effect. You can choose to have physics-based attenuation if you want to, and it will make the sound drop off pretty quickly, because basically what it's doing is it's basically saying, okay, well, if the sound is passing through air, I'm going to reduce the high frequencies as they transmit through the air effectively. So it's going to have attenuation, meaning dropping in volume, based on the physics of the environment effectively. There's also air absorption does somewhat of the same thing, essentially. But yeah, so physics-based attenuation is one of the ways that you can make the sound be quieter in a shorter distance, and air absorption would be another one. So if you take both these on, you'll have a very significantly reduced volume in sound at a fairly short distance away from the original audio source, comparatively speaking. You can have direct sound occlusion. We haven't really covered occlusion in this particular situation. There's documentation about it in our VR class, and also on Steam Audio's own website about it. But we're not really going to be getting into occlusion for this because we're not really putting any sounds in an enclosed space so that there's like no when we're covering up the sound completely. We're not really doing much of that. So in this particular case, we can then have a mix level for our direct mix, which has been set to 1, which is the typical sort of a full volume kind of setup. So that was one half of, kind of what's going on here. Another little part to talk about is the directivity. So this audio source, and the Steam audio source in particular, can have directivity. In other words, it can actually be placed in terms of sort of kind of like sort of like the opposite of a microphone pattern. It's a speaker pattern, effectively, but it resembles a lot of like typical microphone patterns. If you know your microphone pattern options, if you keep increasing the dipole weight, what ends up happening is you go from omnidirectional here to cardioid to hypercardioid to figure 8, basically. And then as you increase the power, it's going to get a little bit more narrower as a result. But in this case, if you just do, say, something like this and a little bit more like that, you get a typical sort of cardioid kind of pattern. And you'll actually see this inside the game space too. We don't have a camera to render at this point in time, so we're not really looking at objects just yet, but we're just doing the flappy sound right now. Well, when we get to the waterfall sound, we'll actually have this loaded up along with our scene. Okay, so this is all pretty much under the category of direct sound and the directivity for that direct sound, essentially. Okay, the next category to talk about is the indirect sound, and that is the reflections, basically reverb, effectively. So it's the reflections off of the geometry in the space of the game. And in this case, what we're basically doing is we're sort of creating a virtual box in our audio manager scene in order for the sound to have reflection in that particular scene. And so you'll want to do is you'll turn on reflections when you do this for indirect sound. So make sure you turn on reflections, and then you can have an indirect mix level that can be in there. And then you'll hear echoes and things like that from sounds. It will depend on the input sound source, okay? So, for example, if you have a very continuous background sound that's just basically noise, you may not really hear an obvious kind of reverberation or reflection happening in our virtual room, effectively. So you'll want to make sure that you have a sound that if you're feeding into this reverb and you really want to hear the reverb work, it's best to have some sort of kind of non-looping sound, essentially, that has sort of more of a transient quality, that so it stops and starts or whatever, in order to be able to really hear that the reflections are going on. Because otherwise, if you have a continuous background ambience, it's not going to be quite as obvious that there's reverb and reflections happening. You can do different kinds of simulation types if you want to, but we're only going to be messing around with real time. You can do baked. Again, there's a lot of documentation in our VR course about that particular thing of what all these options mean, essentially. As I was also saying, there's also, help documentation for Steam Audio as well, if you want to check that out as well. And anyway, so you can have, you can actually turn on binaural audio on the indirect sound as well. And so, that's basically about it. And then there's a few other advanced options there. We basically just simply avoid silence during the init, which is, it can be a useful thing sometimes. So with that being said, we've now made our first thing. We've got Flappy hooked up, and now we can probably play this in the game and we can hear what's going on. Now remember, we're not going to have our flapping sound be happening on awake, because we do not want it to happen on awake, right? We don't want it to happen on awake. We just want it to loop, and then the game will basically control it and turn it on and turn it off and stuff like that, okay? The other thing that we definitely do want to have, though, is we want to have the spatial blend control moved to 3D, okay? We want to make sure that that spatial blend control is moved all the way to 3D. So that's a very important thing to keep in mind. Our maximum distance can be whatever we want it. By default, it's been set to 500 meters, which is pretty long, honestly. But you're going to be basically hearing it pretty well in front of you all the time anyway, because it's the sound of your flapping eagle that you're piloting. So you're only a few feet behind the eagle no matter what. So you probably don't want to have a huge loss in volume anyway. There's a couple of differences. We can have this logarithmic roll-off. You can have linear roll-off. It's important to understand in terms of logarithmic roll. Let me set this to a smaller distance and you'll see what happens. So a logarithmic roll-off means that between the minimum distance and the maximum distance, the minimum distance is how close you can get to your eagle. And again, there's going to be simply in this particular case, there's an object and it's only a specific distance away from the eagle. So you never actually change the distance. It's not like it's a static object and you're walking toward it or anything like that. But if you were, then, when you get here, it would get loud. So essentially, you're going to be a specific distance away from the listener. And then the result will be that the volume will be at a particular space. So this isn't going to be quite as relevant in terms of the situation for the attenuation that's going on with this stuff. This is only going to be more useful for situations in which you have audio sources or objects that are making audio that are at distances where you're able to go, different distances away from them. Instead of having a camera with the listener and the object that's making the sound exactly the same distance away from each other. So, this is not going to be quite as effective. But anyway, we're going to save all of those changes. We're going to try it out inside the game. Now, before we do this, we do need to do one other useful thing. We're in scene 1 at the moment. I just reloaded the scene 1. But we do want to know, actually, we should probably go back to our scene 2, honestly. And I'll go back to my basic view here. So our basic view, right, is going to be basically there. And the deal in this particular case is you're going to go to Steam Audio Manager Settings. And then under the Steam Audio Manager Settings in the inspector, which I will switch to the inspector view, you'll want to basically click Pre-Export Scene. Okay? And to be safe, you should do this for every scene in the game. This is specifically for 3D Steam audio stuff. It should not have any effect at all on an audio source that's been set to 2D and is not using any spatialization whatsoever. Ideally, that should have just worked automatically, like the music that we showed you and the click sound that we showed you. Those things technically do not need Steam audio to work at all, and they don't need any kind of requirements for that situation. What you can do is click Pre-Export Scene, okay? And then you just want to switch to these other scenes and do the same thing. So you want to go to the O3 gameplay scene, find the Steam Audio Manager settings for that one, go and click Pre-Export Scene. And again, over here to the main menu, and you want to find Steam Audio Manager settings, and you click Pre-Export Scene. So with those 3 things done, we should be good to go. Okay, so basically to just mention again, you're going to go to each of those scenes, the 1, the 2, the 3, load them up individually, go to the Steam Audio Manager settings, and then click Export Scene in the Steam Audio Manager settings script, or the Steam Audio Manager script, I should say. Pre-Export Scene, that's what you're looking for, Pre-Export Scene. And then once you do that 3 times, 1 for each scene, right? Then we can go to the main menu and give this a try and see what happens. One last thing, though, to try before we get into things, and this is mainly from an interference perspective. For right now, what we want to do is go to our audio manager, and we're gonna mute the waterfall scene because it's really loud. So we're just gonna basically take all of our ambiences that are here. All we want to hear is our eagle wing flap and see if that will work. So you'll want to go basically here to the 3D Waterfall Ambience, and first of all, it needs to be 3D, so you should pick 3D. And we will add this spatialization in just a little bit, so hang on. But we're going to mute this. So you will temporarily click that mute button just to mute it for now. You could bring the volume down if you wanted to as well. We're just going to do this. We're going to mute this one here too. And even our wind loop, I think, would be a good idea. So we're going to basically take all of our 3D ambiences, or all of our ambience tracks, and just take them out completely, right? So we don't have anything else going. And in fact, to keep it out of the music, again, when we get to the mixer, this will make this much easier. We don't have to deal with this quite so much. But, for right now, we're going to probably want to, check things out just by themselves and see if we can do this. So again, save all these things. Always a good idea to go to that Steam Audio Manager settings because we just changed things in the scene, and click Pre-Export Scene. Now, we're probably not going to immediately hear the results because this is for the reverb, and we don't really have the reverb, we have the reverb area configured, so we'll see what happens. We'll see what happens. So we're going to go back here to the main menu, load that up, and give that a whirl. All right, so let's give this a try. Actually, we're going to do one thing. We're going to maximize this. We're going to take off maximize on play so that we can actually get to some controls when we're doing, because I'd like to actually maybe change some aspects of our flappy sound and see if that makes any difference. There's some interesting differences here. So that's the P key. Okay, so flying our mouse, or flying our eagle, and we should hear our flapping. It's a little quiet to begin with, and then it'll get louder. Probably due to our walls. Yeah. Here we go again. It should be a little louder now. Okay. And again. Okay. So those are the eagle cries, by the way, that are happening every so often. And I think what's happening is it might be interfering with the geometry that we made for the waterfall. You can hear a lot more of the flaps, you know, this way. So, but what I can do is I can actually pause the game. Hang on, hit the escape key. Pause the game temporarily, right? And if you look under Joint Destroy on Load, you'll see the audio manager. So now none of these changes that you make, and you can tell that I'm in playback mode because my screen is now green instead of gray, right? So what happens is that at this point, what you can do is you can change settings on the fly if you want to about stuff, and in order to be able to, you know, create a better result for yourself. So for example, in Eagle Wing Flap, you see how our volume was dropping down pretty heavily, and it's set to 500 or whatever for our max distance. You know, you could set that to much less. You could set that to 50. And that's going to make our volume a lot louder. We could also change our logarithmic roll-off to linear roll-off. And if we do that, our flapping sound is probably going to be a lot louder than it was before. So let's just see what happens. Remember to keep, though, and you can potentially save the settings to this audio source, but if you do make a change to another component, for example, if you make changes to the Steam audio source, you may not be able to remember those changes. You can actually remember these changes, but it's a special kind of consideration. I'll show you in a little bit here. But the idea is, if I click escape again, there we go. So that's our eagle flapping. And you can see we're really close to our listener, so it's not dropping off in volume or anything, right? So we can keep that in mind, that if we set our max distance and our linear roll-off, we'll get a lot louder sound. That's why it's actually dropped out again there. But so if you stay closer to the tree, it seems to be a little bit louder. I'm not quite 100% sure why, but I think there probably is. It has something to do with the geometry that I have around the space for the reverb. So anyway, so the deal though is that, you know, if we basically do that, we get some of the reverb sounds, and you can change things on the fly if you needed to do that, essentially, right? If you wanted to do that, you can change aspects on the fly. So for example, if you go direct binaural, hang on one second. Remember, it doesn't remember any of those changes that I just did, so you have to kind of start all over from scratch. So, but just keep that in mind. Yeah, it's interesting. So when I have these objects this far away, it's clearly running into the interesting. Okay, so what we want to do is go here, go to the audio manager, go to our sound effects, go to our Eagle Wing Flap, and by the way, so whenever you have a setting you would like to make permanent, let's just say, right? For example, let's say it's 50, and you want to make it linear roll-off from this point in time, basically. What you can do now is you can go to the right-hand corner. Let me see that if I can show you the inspector. A little bit of a zoomy thing. So I can go here, And then from here, I can type copy component, okay? So if I copy the component, and I can work on any one component. I can't do it on multiple components, but I can do it on one component. So if I change, settings on that component, it can remember those changes as a copied item, and then I can paste it when I've stopped playing the game, and you'll basically keep those changes there again. So that's a useful thing. If we go here, so now what happens is, if we're back in the game, we've copied our settings, right? Whatever those are going to be, whatever we've set them for, right? I've already copied those settings. I can stop playing back the game now, and I can go back over here to my O2 Audio Manager scene, and then I can go here to the sound effects and Eagle Wing Flap, and then under this, and again, I'll switch back to that inspector view so you can see it a little closer, right? And then you go here, and then basically you can go paste component values. And then that will change everything to what we had before, that linear roll-off, minimum distance 1, maximum distance 50. So now those changes are permanent. We save the scene, and those will be now permanent to the game, essentially, okay? And our third thing, we'll talk about how we get the waterfall going. And we might try a couple of examples of some of these things, like the eagle crying, maybe making the eagle cry work in the spatial audio and stuff as well. So we'll see you in the third and final part, hopefully, for this implementation thing.